Okay, so the next problem looks something like this. There's a pin joint. There's a pin joint to which an arm is attached, and another arm is attached to a piston, which makes this back and forth motion in the cylinder. And so we need to, and what is given is the angular velocity of AB, this arm, is 2000 RPM. Okay, so we need to find VD. Find VD, right? Obviously, VD is going, this is the direction of VD. Let's do one thing. Let's first translate this problem into just a free body diagram. Okay, how do we do that? So we'll just draw an arm for a line representing each arm. I'll probably need more space later on here. And this is A, this is B, this is D. What is given is this angle is 40 degrees, this is 3 inches, this is 8 inches, that angle is 13.9 degrees. So VD goes in this direction, and we need to find that. Omega AB is 2000 RPM. So let's first convert this 2000 RPM into radians per second. Okay, so you have 2000 times 2 pi over 60. So that comes to 209.4 radians per second. That's the angular velocity, and this is going, it's given that it's clockwise. Okay, clockwise. So which means that B will have this, VB is going to be like that. And so VB is going to be in that direction. Now for BD, we need to find, these are the things we need to draw, which is we need to draw the arm. We need to find the center of rotation, the instantaneous center of rotation. We'll call that O. All right, now basically before that we need to find, so the way we attack this problem is we find the distances OB and OD. We find OB and OD, and from that we use the formula V equals R omega. Simple. Okay, but to find OB and OD, we need to find these angles. We need to find which angles? These angles. Okay, now this angle BD, so this angle is easy because this is 90 degrees, so 90 minus 13.9 is 76.1. okay, so angle BDO is 90 minus 13.9 is 76.1 degrees. Similarly, this angle OBD, can be found like this. Look at this triangle OAD, right? Look at the triangle. In triangle OAD, A is 40, D is 90. Okay, so D is 90, So O is going to be, angle O is going to be what? So 130, 50 degrees. O is going to be 50 degrees. Okay. Now if O, and then, so this is 50 degrees. Then we can find, so we know 50, 76.1, so this should be 180 minus 126.1. So that comes to 53.9. 53.9. Okay. So now that we know all angles, it is easy to find sides OB and OD, okay, using the sine rule. Okay, so sine 50 divided by 8 inches, right, opposite. Sine 50 divided by the side opposite to that, 8, is equal to sine 53.9 divided by OD. Sine 53.9 divided by OD. Okay, and this is also equal to sine 76.1 divided by OB. Sine 76.1 divided by OB. Okay, so taking this relationship, we can find OD, and OD comes to, please check my arithmetic, 8.44 inches, and OB comes to 10.14 inches. So now that we know these distances, we use the formula V equals R omega. Okay, V is the linear velocity, R is the distance, radial distance, and omega is the angular velocity. So let's apply this for AB. Sorry. So here we know AB's, we know the distance, we know R, we know its angular velocity, which is given 209.4 radians per second. So radius we know 3, we know omega, we can find V, so that would be VB. So VB is equal to AB times omega AB. Okay, so AB is 3 and omega AB is 209.4, so that comes to 628.2 radians per second. Okay, but VB is also, so VB is also part of the OB. VB, if you look at VB, right, its motion is, B is attached to AB as well as BD, right? VB, the velocity of the joint B is coming from both the arms AB and BD. So now that we know VB, we can use that to find omega. We can use that to find omega BD. So VB is also equal to OB times omega BD. Okay. Now, so OB is 10.14, I believe. Yep. And omega BD is what we need to find. And VB we already found 628.2 0.2. So omega BD is equal to 61.95 radians per second. Okay. All right. Now this omega BD, because this is attached to the instantaneous center of rotation, let's call that IC, instantaneous center of rotation. So this omega BD, right, becomes the system's angular velocity, right? So we can use omega BD to find any of the velocity of any part of that arm. So we're going to use that to find, we know this distance, so we can find VD. We have, so we know the omega, we know R, we can find VD. Okay, so V equals R omega, so VD equals R is OD, right, times omega BD, or you can call that omega system. So 8.44 times, what did you get? 61.95. So when you multiply, you get 522.9 meters per second. Sorry, inches per second, not meters, inches per second.